All right. Hello, everyone. Welcome back to another lecture for maps, mapping, and geospatial technologies. Today, we are going to be talking about Web GIS. So, Web GIS is essentially just GIS that uses web technology. Seems relatively self explanatory, hopefully. Park Map Viewer was the first sort of web GIS technology. So, Park Map Viewer was launched by Xerox in 1993. The features were simple. You could view the map, zoom in and zoom out, and then turn on and off layers, and a little bit more. Even in this early application, we can see some of the fundamentals of web maps today. To show data on the map, the Park Map Viewer would read a request from the user, and using geographic database, it would render a map image and then return the map image from the server back to the browser. This loop, user request, rendering of data, return to the user, still makes up the core of most web maps today. Even the Park Map Viewer URL, which includes parameters for latitude and longitude, is still used in Google Maps today. The early novelty of typing in your address and seeing a red star pop up on the map where their home is was so unique that these services quickly became some of the most popular sites visited online. MapQuest eventually became a publicly traded company and was ultimately acquired by AOL for $1.1 billion in 1999. Of course, it wasn't just the novelty of finding your home on the map, but the ability to get driving directions between two locations. The slow decline of printed road maps had begun, and it was clear that there was a large market available for consumer-based online maps. MapQuest itself added a few basic elements into the web maps we know today. The zoom bar was a new addition to the web maps, as well as the ability to pan the map location. Keeping it simple, client machines asks the servers to do something based on a known protocol. A little bit more advanced, breaking it down into 3 steps. First step is you invoke the web map by making a request from an application or the client. To make this request, you usually use HTTP, a standard protocol that web browsers use for communicating between clients and servers. The request contains structured pieces of information called parameters, which give specific instructions about the task and how it should be executed. Step 2, the server reads the request and runs its web service code, considering all the parameters while doing so. This produces a response, which is usually a string of information or an image. The server then sends you the response and your application uses it. Now for an example, let's suppose you've identified the URL of a web service that out there somewhere that draws maps. You can make a request by constructing a URL and containing the address of the web service and various parameters of the map, such as the format of the image you want to receive, JPEG, PNG, etc., a bounding box, coordinates defining the geographic area you want to see mapped, and the map scale. Paste this into your browser's address bar, and the server sends you a response containing the map image you requested. So for web services, there is web feature service, web map service, web map tile service, and web coverage service. So let's say you've used GIS to map the floodplain for your local area, and you've used that information to determine what land parcels are on the floodplain, as well as the zoning type and property value of each parcel. If you posted the floodplain layer, the parcels layer, and any tabular data that would need to be joined to the parcels on a server for others to download, people with GIS knowledge might find this collection of data very useful. However, casual internet users might be able to download or access these files, but probably would not know how to view them, overlay them, or query them to find out whether their properties are on the floodplain. To help out these casual users, it would be helpful if you could construct an interactive map of this geospatial data and post it online. This type of map would allow casual users to see their property boundaries in relation to the floodplain and determine whether their houses are likely to be flooded. They could also click on their parcel to see the property value and zoning information. Perhaps an aerial photo of their housing development might also be available, showing the locations of nearby rivers and other bodies of water. In addition, the users of the map would have easy access to it through their web browsers. In 2004, the company started the process of acquiring Keyhole, Where2 Technologies, and ZipDash. These three technologies would form what we know as Google Earth, Google Maps, and Google Maps Mobile, respectively. Technically known as a tiled web map, the key lets the map work in this way is the fact that the map image is not one single image, but many tiles stitched together. This matters for a few reasons. First, this is that the tiles themselves are quite small. The size that they came up with is 256 by 256, which became the default for web maps, might be only a few kilobytes. Each one could load quite quickly, and the tile would display when it was returned from the server. Instead of making a full round trip for a complete map each time as MapQuest and Park Map Viewer had, the map tiles would make 10 to 20 very short trips. The maps were also intelligent enough to load tiles that were just outside the map view, so as you started to pan the map, those tiles would be available to you. Maps are pre-rendered at a series of scale levels. Each tile is a PNG, JPEG, or GIF file. This results in faster performance, high-end cartographic quality, raster and vector data layers appropriate for relatively static data, not for data changing frequently. Each zoom level has its own set of tiles, so as you zoom in, there would be another tile layer loaded for that zoom. The entire globe will fit on a single tile at zoom level 0, then it will split into 4 tiles at zoom 1, 16 tiles at zoom 2, so on and so forth. A good starting point for the design of a web map is a base map, a pre-made layer which can lay over other geospatial data. The street map and the satellite image are examples of base maps on which other layers can be displayed, and they can be streamed to you via the cloud and displayed in your web browser. One thing to remember about a base map is that it's a backdrop for your other web map layers to be placed on. So essentially just a picture in the background. A street map base map doesn't actually contain vector line files of the streets themselves, but is rather just static georeferenced image of streets. Aerial and satellite imagery, digital topographic maps, digital street maps, and other reference maps such as OpenStreetMaps can be used as base maps with their own applications. The examples on the slide, this one is imagery with labels. This next one is streets, followed by topography, and last but not least, we have OpenStreetMaps down here. All of these base maps are tiled. So an example of a web service request, the request drills down into the server's folder structure and returns you the requested PNG image as a response. So this is just one individual tile from OpenStreetMaps. This is not the most robust request, but it is one nonetheless. OpenStreetMaps, which began in 2004, slowly gained traction with more contributors and more data added to the map. OpenStreetMap more or less functions as Wikipedia for maps, allowing any registered user to add or edit features on the map. roads, waterways, points of interest, etc. Communities around the world were slowly adding more data to the map. What all these trends had in common was the fact that they were exploring web mapping technology with the same technical base as Google Maps, but using open tools and technology. Two major events took place that would change the way data would be visualized online: the 2010 Haiti earthquake and a change in the Google Maps API. When the earthquake in Haiti took place in 2010, there was no viable online map of affected areas in the country. Google Maps barely had any data, and relief efforts on the ground were left without any maps to navigate Port-au-Prince to provide aid. Per the World Bank, over 450 OpenStreetMap volunteers from an estimated 29 countries were used the imagery to digitize roads, buildings, and other features, creating the most detailed map of Haiti in existence in just a few weeks. OpenStreetMaps quickly became the de facto base map for many of the organizations involved in the response and reconstruction. This is Web Feature Service. Web Feature Service represents a change in the way geographic information is created, modified, and exchanged on the internet. Rather than sharing geographic information at the file level using File Transfer Protocol or FTP. For example, the Web Feature Service offers direct, fine-grained access to geographic information at the feature and feature property level. So I have a little video to play. This is courtesy of Josh Siskind. So I'll go ahead and just play it now.
Using a WFS. This looks like a normal web map. That we may have interacted with before. We have our base map, so all those features are tiled. If I zoom out, and that's compared to what we had before, right? Working so smooth. You can see with those tiles, and I forgot to mention this before, with base maps, you can see how the detail, right, is getting more and more updated. So we talk about cartographic quality. As I'm zooming in, you can see more and more features start to appear. So this multi-scale way of doing the tiles, as I zoom out and zoom in, it's allowing for more and more data to be included. Okay, but we're here to talk about Web Feature Services. So these dots represent the Web Feature Service, the WFS. And as you can see, this is just a very basic sample. Now, if I select on this one feature here, you'll see it has that interactivity to it. We have this pop-up, which gives us an ID of grump v1 settlement points.298. Now, this WFS, we're using, here we go, this get capabilities request. Now, the get capabilities is going to retrieve the metadata about the service, including the supported operations and the parameters and a list of available feature types. This is really all the information that you need to know about it. It's going to give us the list of layers. It's going to give us what we can do with those layers, whether you can create, request, whatever it may be. But you can also make a request to get a feature. You can give it the type name, which is that layer name, which is that grump v1 settlement points. And then we can also request the feature ID of grump v1 settlement points 298. And now you'll see it's going to give us our latitude, our longitude. And now you see all of the attribute information, right? Year of 1988, the continent of Africa. And if we come back to our map, you'll see that starts to all match up. And so this is how a lot of the guts and the background processes of web maps are made. They use web mapping services and web map tile services for the base maps and web feature services in order to give the vector data and the ability to interact with data for the end user.
All right.
Using a WFS.
Oops. So the data you use as layers in web maps has to come from somewhere. For instance, if you're putting together a web map like a floodplain web map described previously, polygons of the floodplain boundary as well as the spatial and attribute data needed to be available in a format that can be served over the web to the end users. This can be data you've created yourself and uploaded to the cloud, data created by others that you've uploaded, or data made available by others online that can import into your map. By combining several map layers, a user can create a new map mashup, which uses different data sets together in one map. Web maps and other website tools are often aided or created with the help of an API, application programming interface, that can be used for web development. An API describes the commands that are available for use and the format of those commands to allow two or more types of software or applications to interface or talk with one another. For example, say you are running a bakery at a particular location and you have your shop's address on your website. When people want to get to your shop, they have to toggle back and forth between two websites because they need to leave your website, go to Google Maps, and type in the address. It would be beneficial to users if they could embed an interactive version of Google Maps in your shop's website to show the bakery's location. To do this, you would use a special type of API. In this case, it would be Google Maps Embedded API to add this functionality to your bakery's website. You can use APIs to create customized geospatial web applications. For example, you can use the JavaScript API for developing web applications for ArcGIS. Other companies, such as Google and Microsoft, provide APIs that allow you to use their mapping products, such as Google Maps or Bing Maps, as functions on websites. Open source products are also commonly used. For example, Leaflet and OpenLayers provide libraries of JavaScript functions for creating maps and geospatial applications for mobile devices and the web. So here is another video I will run through really quickly. So this is a feature service. It's all of the baseball parks in the entire country and a few of them in Canada. And these are the properties that are being shown currently on the screen. So the properties would be what class it is. So obviously these are the major leagues. If it was a minor league, it would say, minors. And then there's the league, again, Major League Baseball. The team it belongs to, the ballpark, and then its position, so the latitude and longitude. There are a lot of these. I will try and go over one at the end. I'll try and find one that I've personally used before and some of the work I've done. I think that's the one we just watched, yeah. So what are the elements of a web GIS application? So there is the base map, which provides reference or context. It's one layer or multiple layers combined into vector tiles. The operational layers, which are thematic representations of your data, what you are trying to show in this map. That could be waypoints, buildings, etc. Interactive map tools, which are tools that perform tasks beyond mapping, such as search, routing, and much more. And then I have another video for us. So these are some different base maps with layers applied on top of them. And then as you zoom in, you get more detail from those tiles. And then this is a geocoding application, so you can click on a building and it will give you information about it. Then in this video, you just change the map view so you can see some outlines on buildings and streets and get quick information by hovering over them rather than having to actually go and click on them. And now in the video, they're drawing an area that he can then go and mark as a parking lot. So he can essentially add an area to it since this is OpenStreetMaps and it is editable by anyone who's a verified user. So, built on ArcGIS Online, Johns Hopkins COVID-19 dashboard, a real-time pandemic tracker, has become a global reference for the pandemic and one of the most cited resources to track the spread of the coronavirus around the world. It has received billions of views and remained highly efficient under a mass amount of web traffic. The World Portal means gate or entrance. It was adopted in the mid-1990s to form new terms such as web portal, referring to a website that serves as a gateway to other websites or web resources. Geoportals are gateways to geospatial information. Portals have become a core component of web GIS technology. For example, ArcGIS Online and portals for ArcGIS have geoportal capabilities. They facilitate the management, search, discovery, configuration, security, and remix of GIS data layers and services. Today, portal collaboration allows different organizations to replace selected content as hosts and guests, creating a portal of portals. A distributed web GIS pattern. ArcGIS Hub and ArcGIS Enterprise sites are examples of subject or initiative-based portals. They provide an easy-to-configure community engagement platform that organizes people, data, and tools through information-driven initiatives. Organizations can create websites to share data, documents, videos, and web maps on a certain subject or for a certain initiative. For instance, the COVID-19 GIS Hub provides GIS resources, solutions, and a collaboration platform for the world to combat the coronavirus pandemic. Geospatial technology is increasingly being used with cloud technologies, where resources are stored at another location but served to a user via the internet. A cloud is structured so that you can store your data on other servers at other locations, but it allows you to access it when you need to via the internet. Similarly, other people can access your data through these servers. However, there's much more to cloud technology than simply serving datasets to users. The cloud structure can be used for a wide variety of geospatial applications. CloudGIS performs the following functions: data, groups, hosting, services, content, apps, maps, and data. CloudGIS is used in the following applications: workflow integration, collaboration, citizen engagement, executive access, work anywhere, and content management. The illustration of workflow integration shows a document. The illustration of collaboration shows people standing on either side in front of a screen. The illustration of citizen engagement shows 3 people standing behind a mobile phone. The illustration of executive access shows 4 people standing beside a conference table. The illustration of work anywhere shows 2 laptops and a mobile phone. The illustration of content management shows a person working on a laptop. So, on to mobile GIS. Mobile is a pervasive client platform for WebGIS. It came to light post-PC era, and it is essentially just GIS for use on mobile devices. So in the post-PC era, mobile devices have surpassed desktops and notebooks as the primary platform for accessing online information. Mobile devices are a part of everyone's life and work. Mobile first is a strategy for many industries, including the WebGIS industry. Consider the benefits. You have mobility, location awareness, which allows location awareness, and then positioning technology, so GPS, cellular networks, Wi-Fi, Bluetooth, etc. User location is often the subject area. Users can see, touch, hear, smell, and feel the subject. Near real-time information, large volume of users, and versatile means of communication. With the increased client-side graphics processing power and the broader support of WebGL, a JavaScript application programming interface that renders interactive 2D and 3D graphics in a browser, WebGIS products such as ArcGIS Online and ArcGIS Enterprise can smoothly create and display thematic and photorealistic 3D web scenes. Representing a big step from 2D online maps, 3D web scenes provide users a more intuitive means to understand their data. Web scenes are also important for indoor mapping, an ongoing trend in GIS. Even more intuitive than 3D, virtual reality allows users with certain visual wearables to immerse themselves in 3D city models by transporting themselves into static viewpoints and comparing different urban design scenarios. This immersive experience brings GIS data and geospatial understanding even closer to users. The GIS community can play an important role in building the metaverse and can assist with getting real work done in the virtual world environment. The term metaverse refers to the fully immersive 3D expansion of existing internet technologies to include AR and VR. In recent years, as map data made its way from the map tile into the browser, web mapping was suddenly opened up to a new group of developers. WebGL was released in 2011 and was built to render graphics more efficiently in the browser. It is used in a wide range of technology, from 3D rendering to video games. As data was made available in the browser at faster speeds, this technology ended up being a good fit for visualizing geospatial data on a map. These innovations grew out of need. There was more and more data being generated that needed to be visualized. One company that struggled with this was Uber, which was sitting on data containing millions of ride records, which could be used to determine everything from surge pricing to finding more efficient ways to move around cities. Inheriting the power of the web and the cloud, WebGIS offers many advantages. Global research, you can share your geographic information easily within your organization and with people all over the world. Large number of users, you can share your app with dozens or even millions of users supported by scalable cloud technology. Low cost per user, the cost of building one WebGIS app is often lower than building a standalone desktop solution and installing it for every user. Better cross-platform capabilities, web apps, especially those built with JavaScript, can run on desktop and mobile browsers running a wide range of operating systems, including Windows, macOS, and Linux, along with iOS, Android, and Windows phones. Easy to use, WebGIS apps typically incorporate simplicity, intuition, and convenience in their design. Public users can use these apps without a technical background, and they are easy to maintain. Web clients can benefit from the latest program and data updates each time they access the web app. The web administrator does not have to update all the clients separately. All right, so that is everything for this week's lecture. So that is just about everything I have. I don't believe I have anything else. Just a couple of reminders. There is a quiz due this upcoming Friday, the 4th. There's also an assignment due this upcoming weekend. I can't remember if it's due Friday or Sunday, so just double check that. And then last reminder, if you haven't already, take a look at that final project and ask any questions if you have any. Hopefully you have already gotten a head start on it so that you don't fall behind. If you have any questions, feel free to reach out. Other than that, enjoy the rest of your week.